In this video, we are going to talk about aqueous solutions. A solution in chemistry is a homogeneous mixture. Now, within the solution, there are generally two components. We have the solvent, which is the part of the solution present in the greater amount, and we have the solute, which is the component or the part of the solution present in the lesser amount. For the solutions we are going to find in this class, there is only one solvent in a solution. So that doesn't mean that there's only one solvent possible. It just means that if you have a solution, only one solvent can be there. Now, if you have a solution, you can have more than one solute. We can have more than one solute. And honestly, that's the case for most of the solutions that we see in our everyday life. If you're making coffee, water is generally the solvent. And then you have coffee beans, creamer, sugar, whatever else you want to put in your coffee. In this picture, we have a solution being made by adding a white solid to a clear colorless liquid. This could easily be adding salt to water or adding sugar to water. Now, aqueous solutions are where water is the solvent and the compound or molecule that is being dissolved in the water is the solute. In order to have an aqueous solution, we need to have a solute that is soluble in water. So let's talk about how we can predict solubility. We can do that in terms of what are called electrolytes. We have three different types of electrolytes we're going to talk about in this class. We have strong, weak, and non-electrolytes. A strong electrolyte is something that completely dissociates in solution. Now, dissociation or dissociates just simply means that it breaks up in solution. Because solution can be kind of a long word, we sometimes use the abbreviation SOL apostrophe. So that means solution. So a strong electrolyte is something that completely breaks up in solution. It completely dissociates in solution. So an example of that might be something like sodium bromide. If I have the ionic compound sodium bromide, it is a solid. And when I put that in water, it is going to completely dissociate. It completely breaks up into sodium ion and bromide. Notice that my states changed from solid to aqueous. Some properties of strong electrolytes are that there are only ions in solution. There's only ions in solution, there's nothing else. So what that means is they are strong conductors of electricity. In order for a solution to conduct electricity, it has to have ions present. If you only have ions present in solution, then it is going to conduct electricity and it's going to do so very strongly. So, how can we identify if something is a strong electrolyte? Well, it has to be an ionic compound and it has to be soluble in water. So, it is a soluble ionic compound. So look for a metal. Does it have a metal? If yes, check to see if that compound is soluble. If it has a metal and it is soluble, then you're dealing with a strong electrolyte. Strong acids and bases are also strong electrolytes. Strong acids and bases are actually defined in the same way as an electrolyte. A strong acid is something that completely dissociates in water. A strong base is something that completely dissociates in water. All right, let's look at our weak electrolyte. So a weak electrolyte partially dissociates in solution. Partially dissociates in solution. Now, an example of that might be something like hydrofluoric acid. Now, hydrofluoric acid, when we put that into water, it is going to break up into hydrogen ion plus fluoride. However, because hydrogen and fluoride are so small and they're charged, they're really going to be attracted to each other. So as soon as they split up, that positive and negative attractive force is going to just cause them to get right back together. And we represent that by drawing an arrow going back to the reactants. So this double arrow is called equilibrium. It is equilibrium. And equilibrium is just having a forward and reverse reaction happening at the same time. And what's neat about equilibrium is that as soon as your reactants form the products, your products turn around and form the reactants. So you get this back and forth happening. So in solution, since my products are getting back together to make my reactants, we have both ions and molecules in solution. So since we do have ions in solution, it will conduct electricity. However, we don't only have ions. Because those ions are getting back together to form the molecule, we have molecules as well. So they are weak conductors of electricity. And when you are trying to define or identify whether something is a strong, weak, or non-electrolyte, when you want to identify it as a weak electrolyte, it is a weak acid or a weak base. You can also look at the arrows if you're given the equation. Anytime you see this equilibrium, that is always going to be an indicator of a weak electrolyte. Finally, a non-electrolyte is exactly what it sounds like. It does not dissociate at all. It does not dissociate in solution or when dissolved in water. So an example of this might be sugar. So glucose is a component of sugar. and it starts out as a solid. When we put that in water, we know it is soluble. So don't confuse non-electrolytes with not soluble because they're still soluble. What happens is they don't break up. So instead of being a solid, it now becomes aqueous because it has gone in solution. In a solution containing non-electrolytes, there are only molecules. So if there are only molecules in solution, there are no ions in solution, then non-electrolytes do not conduct electricity. You can identify a non-electrolyte because it is a molecule. Sometimes you might hear insoluble salts as non-electrolytes. However, they're really in their own category. They're not soluble, so there's not a solution, and that's that. Remember, a salt in chemistry is any ionic compound. Here is a little graphic to give you an idea of what these look like. A non-electrolyte, which water is a non-electrolyte, when you put the electrodes from a light bulb into a solution or a sample of pure water, you'll see the light bulb does not light up. Nothing happens. If you have a strong electrolyte, the light bulb will light up pretty intensely. And you can see these ions are going to be moving all around. The When you put this into the electrodes into the solution, the positive ions are going to go screaming towards the negative side, and the negative ions are going to go screaming towards the positive side. And that causes the ability to conduct electricity. In a weak electrolyte, the light does not get lit up nearly as much. You're still going to have some movement going to the different electrodes, but not as much because there's not as many ions present. The concentration of the ions is so much smaller.